Crash course on data science. Data science, statistical inference, explore how we can make meaningful conclusions from data, even when we can't observe the whole population. Data science is the field that combines mathematics, statistics, and computer science to extract knowledge and insights from data. One of the most important techniques in data science is statistical inference, which allows us to make meaningful conclusions from data, even when we can't observe the whole population. Statistical inference involves two types of statistical reasoning: estimation and hypothesis testing. Estimation involves using sample data to estimate population parameters, such as the mean or standard deviation. Hypothesis testing involves making a decision about a population parameter based on sample data. To perform statistical inference, we need to use probability theory, which provides the mathematical foundation for statistical inference. Probability theory allows us to calculate the probability of observing a certain outcome, given a set of assumptions about the underlying population. Here are some key concepts in probability theory that are used in statistical inference. Probability distribution, a function that describes the likelihood of different outcomes in a random process. Random variables, variables whose values are determined by chance. Probability density function, PDF, a function that describes the relative likelihood of different values of a continuous random variable. Cumulative distribution function, CDF, a function that describes the probability that a random variable takes a value less than or equal to a certain value. Sampling distribution, the distribution of a statistic, such as the mean or standard deviation, computed from a sample of data. Here are top 12 interesting statistical inference examples. 1 medical trial. A pharmaceutical company wants to test a new drug for a rare disease. They recruit 100 patients with the disease and randomly assign them to two groups. One group receives the new drug, and the other group receives a placebo. After 6 months, they measure the proportion of patients who are cured in each group. They use a hypothesis test to determine if the new drug is more effective than the placebo. 2 election polling. A polling company wants to predict the outcome of a presidential election. They conduct a survey of 1,000 likely voters and ask them which candidate they support. They use the sample proportion to estimate the true proportion of voters who support each candidate, and they use confidence intervals to quantify the uncertainty in their estimates. 3 quality control. A manufacturer wants to ensure that their products meet a certain standard of quality. They randomly sample 100 products from the production line and measure a certain characteristic, such as the weight or length. They use the sample mean and standard deviation to estimate the true mean and standard deviation of the characteristic, and they use hypothesis testing to determine if the mean is within the acceptable range. 4 environmental science. A researcher wants to determine the effect of a certain pollutant on a population of fish. They sample 100 fish from a lake and measure their length and weight. They use regression analysis to determine if there is a significant relationship between the length and weight of the fish, and they use the regression equation to predict the weight of the fish based on their length. 5 marketing research. A company wants to test the effectiveness of a new advertising campaign. They randomly assign 1,000 customers to two groups. One group sees the new ad, and the other group sees the old ad. They measure the proportion of customers who make a purchase in each group. They use a hypothesis test to determine if the new ad is more effective than the old ad. 6 social science. A researcher wants to study the relationship between income and education level. They sample 1,000 people from a population and ask them about their income and education level. They use correlation analysis to determine if there is a significant relationship between income and education level, and they use the correlation coefficient to quantify the strength of the relationship. 7 finance. An investor wants to determine the expected return and risk of a portfolio of stocks. They collect historical data on the returns of each stock and use the sample mean and standard deviation to estimate the true mean and standard deviation of the portfolio. They use portfolio theory to determine the optimal allocation of stocks that maximizes the expected return and minimizes the risk. 8 sports analytics. A coach wants to determine the effect of a certain training program on the performance of their athletes. They randomly assign 100 athletes to two groups. One group follows the new program, and the other group follows the old program. They measure the performance of the athletes before and after the program and use a hypothesis test to determine if the new program is more effective than the old program. 9. Criminal justice. A prosecutor wants to determine if a defendant is guilty of a crime. They use the evidence collected at the crime scene to estimate the probability of observing the evidence if the defendant is innocent. They compare this probability to the probability of observing the evidence if the defendant is guilty, using Bayesian analysis to update their beliefs about the guilt or innocence of the defendant. 10. Climate science. A researcher wants to determine the effect of greenhouse gas emissions on global temperature. They collect historical data on greenhouse gas emissions and global temperature and use regression analysis to estimate the relationship between the two variables. They use the regression equation to predict future global temperature under different scenarios of greenhouse gas emissions. 11. A/B testing in online marketing. An e-commerce website wants to determine which version of their website design leads to higher conversion rates. They randomly assign half of their visitors to the original design, Group A, and the other half to the new design, Group B. They measure the conversion rates of each group and use hypothesis testing to determine if the new design is more effective at converting visitors to customers. 12. Quality control in manufacturing. A manufacturer wants to ensure that their production process is consistent and meets quality standards. They collect a sample of products from each production run and measure a quality characteristic, such as weight or length. They use statistical process control, SPC, to monitor the process and detect any deviations from the target value. SPC allows them to make adjustments to the process and maintain consistent quality over time. These examples illustrate the wide range of applications for statistical inference in various industries and domains. By using statistical inference, organizations can make informed decisions and draw meaningful conclusions from their data. In summary, statistical inference is a powerful tool for making meaningful conclusions from data. It allows us to estimate population parameters, test hypotheses, and quantify uncertainty. The examples listed above demonstrate the broad applicability of statistical inference to a wide range of fields and applications. Here is a poem on statistical inference. Inference is the art of data science, where we draw conclusions from a sample, not the whole. Probability, the foundation of the craft. Calculating the likelihood of each role. Estimation and hypothesis testing. The two types of reasoning at play. Sample data used to estimate parameters. Then decisions made in a hypothesis test way. Medical trials, election polling. Quality control, environmental science. Statistical inference applied. A tool that proves its relevance and reliance. Marketing research, social science. Finance, sports analytics, criminal justice. All use the power of statistical inference to make informed decisions with little fuss. Climate science, the study of the Earth. Regression analysis used to estimate the effect of greenhouse gas emissions on global temperature, an important debate. Statistical inference, a versatile tool with broad applicability and practical use. An essential skill for data science. And the knowledge we can all peruse. ******. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html $aid = 7989335 as a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for support our AnHub Metaverse channel, and please watch more interesting videos here.